picture the night sky for a second. When you step outside on a super clear, dark night and just look up at the stars, everything seems so permanent, doesn't it? It looks like this grand painted ceiling just hovering right above us in absolute silence. But you know that quiet, majestic canvas? It's actually hiding literally the most dramatic, high-speed and mysterious ongoing event in the history of, well, everything. Today we're diving into this explainer on the mechanics of metric expansion and the absolute undeniable fact that our universe is far from finished. It's alive, it's highly dynamic, and as you can probably guess, it is still expanding.
Chapter 1. A universe in motion, shattering the static illusion.
Okay, let's dive into this. It's a really simple question, but it totally sets the stage for everything we know about cosmic mechanics. Did you know the universe is not still, like at all? For most of human history, people just naturally assumed the cosmos was this fixed, rigid container holding all the stars and planets in a nice, steady arrangement. The classic view was kind of just the space between things is an empty void, sitting completely motionless. But as anyone tracking modern astrophysics knows, the data tells us a completely different story. The universe is absolutely anything but static.
The wild reality is that the cosmos is growing bigger every single second. Right now, literally as we speak, the very fabric of space around us is actively stretching. It's this continuous, completely unstoppable motion. And hey, it's not just happening way out there on the distant, blurry edges of some cosmic boundary. This metric expansion is a fundamental property of the universe we are sitting in right now. But, to really wrap our heads around the mechanics of this continuous growth, we've got to look all the way back to where this incredible motion actually started. Which brings us to Chapter 2, the Big Bang origin, where space began.
13.8 billion. Let that number sink in for a second. 13.8 billion years ago. That is the exact timestamp scientists point to for when absolutely everything kicked off. It's an incredibly massive baseline fact that anchors our entire understanding of reality. Because think about it. Before this timestamp, there were no stars, no galaxies, no matter. Honestly, not even time or space as we know them existed. Now, we usually picture the Big Bang as like this giant explosion happening inside a giant empty dark room, right? Well, actually, scratch that. That's fundamentally incorrect. When the Big Bang occurred, as light and particles spread outward, space itself began expanding. This is an absolutely crucial distinction to make. The Big Bang wasn't an explosion in space, it was literally an explosion of space. The very fabric of reality was born and just immediately began stretching outward. Moving on to part 3, the balloon analogy, visualizing the stretch. So as our source material perfectly puts it, since then, galaxies have been moving away from each other, like dots on a balloon being blown up. It's honestly such a brilliant mental model. Just take a second and imagine massive galaxies, packed with billions of stars slowly drifting away from one another, carried along by this massive, invisible stretching force. Think of it like this. Imagine a totally deflated balloon, and you just draw some dots on it with a marker. Those dots, those are our galaxies. Now, as you inflate that balloon with air, you watch those dots move apart from each other. Notice how the dots themselves aren't actually sliding across the rubber, right? The rubber itself is what's expanding. And because the dots are just chilling on the rubber, the distance between them grows. That rubber surface perfectly mirrors how metric expansion works. The actual space between the galaxies is what's stretching, carrying everything along for the ride.
And that brings us to part 4, the expansion plot twist, speeding up.
Okay, think about standard everyday physics for a moment. What you'd expect from literally any kind of explosion or outward force is that it eventually runs out of steam and, well, slows down. I mean, if you throw a baseball straight up into the air, gravity eventually catches it and pulls it back down. So scientists logically assumed the universe would do the exact same thing, that the massive collective gravitational pull of all the stuff in the cosmos would eventually pump the brakes on the expansion. But the data reveals what's actually happening, and it's a total game changer. The expansion is speeding up. No way, right? Not only are the galaxies moving apart, but they are doing it faster and faster every single day. Which, of course, naturally leads us to a massive, mind-bending question. If gravity is constantly trying to pull everything back together, what in space is strong enough to completely overpower gravity and push the entire universe apart at an accelerating rate? Let's look at Section 5, the dark energy mystery, the unseen force. Enter dark energy. It's this incredibly mysterious force scientists believe is pushing everything apart faster and faster. We can't see it, we can't touch it, but we can measure its immense effects spreading like these unseen waves through the entire cosmos. It's essentially the ultimate invisible engine, driving our metaphorical balloon to inflate at a rapidly increasing speed. And get this, it makes up the vast majority of the total energy density of our universe, yet the exact nature of what it actually is remains one of the absolute greatest scientific mysteries of our time.
So, to sum it all up, the universe is alive, it's expanding, and it is full of mysteries. It is absolutely not some static, boring container. It's a dynamic, living entity that is actively evolving right this very second. The space around us is undergoing constant metric expansion, completely driven by this invisible, dark energy that's just accelerating the growth of the cosmos at a scale that's honestly beyond human comprehension.
So what does this continuous accelerating expansion actually mean for the ultimate future of everything? If space just keeps stretching faster and faster forever, what ultimately happens to all the galaxies, the stars, and the very fabric of reality itself? It's a profound, kind of chilling, but incredibly beautiful mystery to leave you with today. Keep looking up, keep asking those big questions, and I'll catch you on the next explainer.